Hello fellow science enthusiasts and welcome to my channel. I'm Jared Lautenschlager. Thanks for stopping by. Today I will be covering the solar system in the first of my astronomy videos. We'll briefly go over all of the objects in our solar system with more in-depth looks at each of the planets, the moons that orbit them, and the sun in later videos. So let's go ahead and get started. So a solar system is a gravitationally bound system with a star and objects that orbit it. In our solar system, we have 8 planets, with some of those planets having moons, as well as other objects such as dwarf planets, comets, asteroids, and meteoroids, and each of these objects orbits a sun, which lies at the center of the solar system. This is what is known as heliocentrism, which basically means that the sun is the central point of the solar system. So how did our solar system come to be? Well, roughly 4.55 billion years ago, a dense cloud of interstellar gas and dust collapsed, possibly due to the shockwave of a nearby exploding star, which is called a supernova. When this dust cloud collapsed, it formed a solar nebula, which is a spinning, swirling disk of material. Gravity caused the disk to flatten, with most of the gases forming at the center. Extreme heat and pressure caused the formation of our sun, with the remaining gases and dust particles forming the planets. The planets that formed closest to the sun are known as terrestrial planets, and the ones that formed further away are known as the ice and gas giants. The ice and gas giants formed furthest away from the sun due to the strong solar winds, which pushed the lighter gases, such as hydrogen and helium, further out into space. Our solar system sits within a galaxy that we call the Milky Way. The Milky Way galaxy is a spiral galaxy with curved arms of stars emanating from its center. Our solar system forms one of the smaller arms called the Orion Cygnus arm, or just simply the Orion arm, and it sits about 25,000 to 30,000 light years away from the supermassive black hole that lies at the center of our galaxy. More on that later. The boundary of the sun's gravitational influence extends about 122 astronomical units, where 1 astronomical unit is the average distance between the Earth and the sun, or about 150 million kilometers. For those of you in my audience that are not familiar with the metric system, that is roughly 93 million miles. In total, our solar system is roughly 287.46 billion kilometers, or 178.61 billion miles in diameter. To put that into perspective, if our solar system were the size of your hand, the Milky Way galaxy would cover the United States. And that is only one galaxy out of the nearly tens of thousands in the known universe. Suffice it to say, the universe is a pretty big place, and we'll have plenty to cover in subsequent videos. So now let's take a look at those planets that I mentioned earlier. In order from the sun, the planets of our solar system are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now I know what you're thinking. Hang on, that's only 8. I thought we had 9 planets. What about Pluto? Well, back in 2006, Pluto was demoted from planetary status by the International Astronomical Union and was dubbed a dwarf planet. Now there's really only one key distinction between a planet and a dwarf planet, and that is the area surrounding each celestial body. There are 3 basic criteria an object must meet in order to be considered a planet. It must be in orbit around the sun, it must have sufficient mass to assume hydrostatic equilibrium, which means a nearly round shape, and it must clear the neighborhood around its orbit. A dwarf planet has not cleared the area around its orbit, while a planet has. Clearing its orbit means that there are no other bodies of comparable size other than its own satellites or those otherwise under its gravitational influence in its vicinity in space. Since this new definition, 3 objects in our solar system have been classified as dwarf planets. They are Pluto, Ceres, and Eris, and they join Makemake and Haumea as the only dwarf planets in our solar system. Although there are some in the scientific community that believe that there may be as many as 50, but these other dwarf planets have yet to be found. I will honor Pluto with its own video later on, so don't worry too much about that. There are also moons in our solar system. Well, more precisely, there are about 200 moons. These natural satellites orbit planets and sometimes even asteroids. Most of the moons orbit the giant planets, with Saturn and Jupiter leading the moon counts, but even smaller worlds like Pluto can have up to 5 moons in orbit. Moons come in many shapes, sizes, and types. Most of the moons are airless, like ours, but a few actually have atmospheres and even hidden oceans. In fact, it is thought that a few of the larger moons, in particular Europa and Enceladus, could potentially support life. Although any life found on either of these 2 moons would be most likely only be subsurface and microbial at best. Now, those other objects that I also mentioned earlier are the comets, asteroids, and meteoroids that are floating around in space. And at first glance, these might seem like they're the same thing, but upon closer inspection, you'll notice a few things that separate them from each other. Asteroids are typically small, rocky objects, usually around 10 meters in diameter or greater, that orbit the Sun. Most of the asteroids are located in a region known as the asteroid belt, which lies in a space between Mars and Jupiter. Some asteroids, however, do wander throughout the solar system, and some have hit the Earth in the past, most notably during the time when the dinosaurs were still around. Comets are also in orbit around the Sun and are also made of rock, but one key difference is that they have a visible tail of gases that follows behind them, whereas asteroids don't. This tail is formed when the Sun warms the ice that covers comets, which causes the gases to be released, giving the comet its distinct look. Meteorites are pieces of space rock that have fallen to Earth and have helped scientists figure out the age of the solar system. Some of these small pieces of space rock, or meteoroids, have broken off moons and planets and can yield very interesting scientific information about the chemistry and history of their home body, while others have been traveling around in our solar system since that primordial dust cloud collapse before those planets existed. The Alende meteorite, which fell to Earth in 1969, is the oldest known meteorite, and scientists have dated it to 4.55 billion years old. Occasionally, you might look up in the night sky and see what is known as a meteor shower. This is a collection of meteors that is visible when the Earth passes through a trail of debris left behind by a comet. There are many comets, asteroids, and other small bodies that are believed to be contained inside a circumstellar disk known as the Kuiper Belt. It extends from the orbit of Neptune at around 30 astronomical units, all the way to about 50 astronomical units from the Sun. It is similar to the asteroid belt, but is far larger, roughly 20 times as wide and about 20 to 200 times as massive. So what's left? What lies beyond our solar system? Well, some of these things are black holes, stars even bigger than our Sun, and many other objects that are floating around in the vast expanse of the universe. But nearer to our solar system, there is what is known as the Oort cloud, sometimes called the optic Oort cloud. It was first described in 1950 by Dutch astronomer Jan Oort and is a theoretical cloud of predominantly icy planetesimals proposed to surround the Sun at distances ranging from 2,000 to 200,000 astronomical units. Remember, 1 astronomical unit is the average distance from the Earth to the Sun, which is 150 million kilometers. So this would be very, very far out in space. Although this Oort cloud has never actually been directly observed, and it remains entirely hypothetical. Well guys, that is going to do it for this episode. I hope that you learned a lot about our celestial neighborhood. If you have any questions, feel free to ask them in the comments section below, and I will do my best to answer all of them. All the links to the information in this video will be linked down below, as well as links to my social media pages. Be sure to give the video a like and subscribe to the channel if you haven't done so already. Also, don't forget to click the little bell icon so that you can catch my new videos as they release. Thanks for watching guys, and I will see you all later.